All right, guys, I want to talk about problem solvings in chemistry. Okay, I know it's a math-based course, so this is something I'm going to kind of go over now, think about it, and you're going to have to come back to this later on when we start doing more mathematical problems. Okay, okay, so skills used in solving problems. Now, effective problem solving always involves developing a plan and then implementing that plan. So look at what you're given, what you're trying to figure out, and map it out. You want to go from something that you're given, whether it be in grams, to convert it to something else. So you're going to have a roadmap of some kind of conversion mathematically here. So down the road, we're going to be doing something with dimensional analysis. So for example, dimensional analysis in conjunction with your knowns, which we say are what is given in a problem, to find out our unknowns, which is what we're looking for or our wanteds. So you gotta more or less understand the variables that you're handed. So when I give you a problem, look at that problem, extract the given information from it, and kind of formulate a map of where you want to head. If you're unsure, write it down on paper. Givens and wanteds. Go from here to there. Start it out. You're not going to be able to find it out right the first time. Write it out, get it out, work it out, and try to learn. I know everybody's not going to be the greatest at it at first, but it does take a little bit of time for some people to develop the skills to understand how to actually go about solving a complicated multivariable problem or even a multi-step problem. And we're going to work on that down the road. So always be conscious about the problems that you're working with. Okay? You really have to slow down and look at the information that you have in your hand or in the problem. Okay? So, the steps for solving a numeric word problem are the following three steps. Okay, the first step is analyze. Okay? Now what you want to do is you want to read the problem, identify where you are starting from, the knowns, and where you are going, the unknowns. All right. Then you want to make a plan what to solve for. Me, I've been doing this a long time. I see it 1, 2, 3 what I'm looking for like instantaneously. I know what to do because I'm like a pro at it. I've been doing it for a long time. You guys are new at it. So you have to slow down. You have to figure out what you're looking for, what to solve for. Okay? Now, if you need be, draw a diagram if that helps you visualize it. Okay? Then you want to use conversion factors. And then we're going to learn that down the road what conversion factors are. An example of a conversion factor would be like 1 dozen equals 12 eggs. There's 1 dozen equals 12 eggs. So 1 equals 12. 1 over 12. 12 over 1. Those are conversion factors. And lastly, determine which formulas you're going to be utilizing. Because later on, we're going to be dealing with density, gas laws. Okay, so you want to make sure you have the correct formula to use. Okay, in this class, there aren't too many formulas compared to what there are in physics. Now, the second step is calculate. Okay, this is actually the easiest part. Once your plan is set and you know what unknowns you are looking for, calculate using your knowns and the plan you developed. So this is where you want to use your algebraic skills. Okay, don't forget about the math book. Math handbook in the appendix. Okay, every chemistry book has an appendix which has a little bit of review of some basic algebra skills that you need to be familiar with. Okay, so you can look into that as well. And I highly recommend that, just reviewing that. Now the last step is one of the most important steps. Some students overlook this step, but it's very simple. You might have made a mistake in calculating. You might have hit the wrong button on the calculator. You might have wrote the wrong variable down. I don't know. Okay? But you always check by using evaluation skills. So when you evaluate, you must first ask yourself, is this answer reasonable? Okay? So if you're asked to give a mass of somebody, okay, let's take me, 200 pounds. Okay, so let's say you had to calculate your mass, which is known to be 200 pounds. However, you calculated 200,000 pounds. Okay, do I look like 200,000 pounds? I'm not 200,000 pounds. I mean, someone might say maybe 400 pounds, maybe 100 pounds, 180, in the ballpark, but 200,000 pounds, you're way off. You have set something up in your problem somewhere incorrectly. Okay, something does not seem right. All right, so you have to go back and check all your math work out. All right, and last thing is, one of the most important things to check is to see if all your units were canceled correctly, and if you're asked for mLs, you don't have a liter. Okay, so make sure that you're answering your question in what it's asking it to be answered in. Don't go make something up. Okay, some kids have a little difficulty solving the problems, and they end up just trying to get done really quick and not caring what the answer is. You already put the effort in. You might as well just put a little extra effort in to get to the end, to the correct answer. Just hold on just a little bit longer. Don't throw in the towel so fast. Some kids get it 1, 2, 3. No problem. Okay? So these are 3 steps, and it's known as ACE. Analyze, calculate, evaluate. Something that you're probably like, what the heck's he talking about right now? But later on, we're going to be using this a lot, and it's a tool that I use to make sure, okay, my answer is just about right. Okay, sometimes I even make mistakes. I hit the button wrong on the calculator by accident. Whatever, the button's stuck. You never know. You want to evaluate everything. Okay, all right, that's it.